So my name is Morris Alper. Um, I'm originally from Palo Alto, California, and I studied at MIT, graduated a few years ago, and since then I've been working in data science and specifically working with natural language processing, or NLP. So my background is actually in mathematics and linguistics. I was always interested both in math and STEM and also in linguistics and languages, and I kind of wanted to find a way to incorporate all of these interests. And so in the end, I wound up focusing on NLP, which is something which really interests me because it does combine both technology, science, and math, and also language, understanding language. So the idea behind NLP is making computers able to understand natural language, which could mean either text or speech, anything that deals with language that humans use. So for a person, it's quite easy to understand what language says. If you read a text, you can understand it easily, but usually things that are easy for people are hard for computers. So computers are good at following lists of rules, and it's really hard to think of how you would write a list of rules to understand what a sentence means. Actually, you could probably sit your whole life and never be able to finish. So being able to write computer programs that can use language and understand language is quite difficult and also important because we use language in our daily life and we expect computers to be able to understand us. That's the
Right,
basic.
right. I mean, it's interesting because I've seen a lot of stuff in like the popular press about AI and NLP, and sometimes they just get it so extremely wrong. It's not even funny. So one of the ideas that's floated around in radiology, especially, is that there's going to be this curve of like, what people think AI will do, and then there'll be like a crash of expectations. And I've seen graphs where they put NLP as like, essentially they say it's a technology that might happen, but that's wrong. I mean, there have been journals in NLP for like a quarter century. Like I looked this up last night. This is not really that new, right? I mean,
Yes, so NLP has been around basically as long as computers have. I think people were always interested in having computers be able to understand language. Now, there have been a few waves of progress in NLP. So people started with rule-based systems, like I alluded to before. And it wound up becoming pretty clear that that's not feasible for complicated problems. And so since then, NLP has mostly shifted towards machine learning, which basically means where the algorithm learns the rules by itself instead of a person sitting down and defining all of them. That was quite a revolution. And I would say nowadays we have a revolution within machine learning that's mostly powered by deep learning. So there have been some advances that have made it much more feasible to make these big neural networks, which is a kind of algorithm which is kind of inspired by how a person's brain works. And because of increased computing power and some clever ideas, we've now been able to train these things on a much larger scale than before. And that's brought some really big improvements. But that being said, NLP has been around for a long time, as you said.
right.
Yeah.
So on the one hand, like everything in AI, it's brought some really big improvements. There also is an argument to be made that it's brought some big problems, right? And I think it's interesting. I was reading recently that with some of these automated systems, what they're already seeing is that for various reasons, a person's social status heavily influences how much of an appeal they can make towards an automated system. So like a poor person might be handled by some automated system and never be able to get the algorithm, never be able to understand it, and never be able to appeal it. But if a person of high social status can sort of appeal the algorithm and get to a human much easier. So if unfortunately, like, we're going to say dole out healthcare by algorithm to poor people, which sounds terrible, but this may become a reality, then like we should get it right. And maybe, there are a lot of, I know there are a bunch of cases where people aren't getting these things right, unfortunately. So that's probably a good background to introduce this paper that you introduced me to, which is really awesome because it actually looks at algorithms that are like kind of a solution to a related problem, which is like basically when you have bias in the data that you're training on, essentially, if I understand the paper correctly.
Yes. So this is a general issue, which is, well, first of all, I'd just like to say that in general, I think there's kind of a misconception that computers or machine learning is magic, which it really isn't. So just because you can train a computer to do something useful, it doesn't necessarily mean that it's magic or that it's able to infer anything beyond what's in the data. So what do I mean by that? Well, there are a few important points, but one of the biggest ones is that basically the machine will learn what you teach it. And so it's very influenced by what you're deciding to teach it and what patterns are present in the data. And if the data was generated by people, it's probably going to be influenced by the biases that people have. For example, in NLP, we're training a lot of models on huge amounts of text, which might be from the internet, for example. And all of that text was originally written by people who have their own inherent biases. So the specific case in this paper, which I showed you, is talking about an issue with what's called word embeddings. So I won't go into all of the details, but the basic idea is that usually when we're training these algorithms, it's easier to work with numbers than words. So we try to assign a vector, which is like a group of numbers to every word. And then you can do some statistics on that. And so the idea will be that words that have similar meanings will have vectors that are close to each other. So the numbers will be close. And those are trained on huge amounts of text from the internet. So it's looking at words that usually come in similar contexts or occur together. And it's assuming that those have similar meanings. So in general, that works well, but it's biased by the kinds of things people write about. And so one thing which was found, for example, is that the word for man will get some vector that's closer to words that are stereotypically male things, and the words that are close to the vector for woman will be closer to stereotypically female things, because people tend to write about those in similar contexts just because that's the bias that people have on average when they're writing. So it was found, for example, that male words will cluster with some words like philosopher, captain, architect, all sorts of different things. Whereas female words will cluster with homemaker, nurse, librarian. All of those are not inherently gendered words, but they're kind of gendered by people's biases. And so if someone could just delegate responsibility to a machine and say, okay, well, the machine makes numbers for all these words, and then it runs some algorithm, and whatever result it gives, that's the machine did it. It's not my fault. But really, it's going to, if you're inputting word embeddings that have this bias in it, then you would expect that whatever predictions it makes will also have this bias in it. So you actually, as a data scientist, you have to take some responsibility and consider that this might happen and possibly try to correct for it. So this paper, which is called Man is to Computer Programmer as Woman is to Homemaker, debiasing word embeddings, is talking about basically an algorithm to try and avoid these biases being present in word embeddings in assigning vectors to words. But it's a very general problem.
Yeah, I mean, what I think is interesting is that while in some cases you could say there's a statistical truth that is underlying some of these closer vectors, like it turns out man, I believe, is closer to doctor, and the parallel would be like woman is closer to nurse. Well, statistically, you know, although I'm a doctor, I do realize that there are more female nurses, but some of these sort of parallel vectors turned out words that had similar meaning but very different connotations, like man is to superstar as woman is to diva. Like when I think of diva, I think of someone very negative and nasty, and superstar is like awesome. So really, what are you saying? Like if you take out if you just look at the connotation, it's like men are awesome and women are, you know, crazy people who want green M&Ms. Like, I mean, which
Yeah.
I don't know,
Um,
you know.
yeah. I'll also say, I think it wasn't mentioned in this article, but it's also been found that these classic word embedding models uh, tend to have some racial bias. So for example, if you look at words that cluster close to stereotypically white or black names, uh, actually there can be an issue of like, say, stereotypically black names being closer to words with negative connotations, which again is something which the algorithm naively just found from the distribution of words in whatever text it was trained on. So it's basically just reflecting something about the text, which reflects something about the people who wrote the text, and what they chose to write about and how. So just the fact that it was generated by a machine doesn't mean that it's not biased.
Actually, in some of the things I've done with machine learning, what I've actually found is that oftentimes it can demonstrate to you a bias you weren't aware of if you look at it the right way. But unfortunately, I think it's so new that a lot of people aren't looking at it the right way, and they just have this automation bias where they feel like, well, the computer said it, and therefore it's true, and therefore I don't have to take any responsibility over this algorithm that is potentially hurting people because the computer said it.
Right, right. So really the computer does what you define it to do, and then it's usually trained on data which was at least indirectly produced by people as well. So yeah, I agree with you that that thought process is kind of dangerous. And now it's become a pretty big topic of discussion how to correct for this. And there are a few different lines of thought as to how to do it. And there isn't really one correct solution. There are a lot of different ideas, but it's still kind of an open question.
So what do you think is the ethical way to deal with statistical differences? If some of these word embeddings are statistical differences, like statistically speaking, let's say in the corpora of Western text, women are more likely to be sitting at home and men are more likely to be computer scientists. What is there an ethical question there or
Well,
not?
I think there is because um, first of all, whatever bias is present in society, if we just make naive algorithms without taking it into account, I think we'll basically just wind up reinforcing whatever bias we already have. So it can kind of create a feedback loop. Um, I don't think we should passively accept it. Um, Also, on a high level, before talking about more specifics, I also think that um, it's important to have uh, a diverse group of people actually considering these problems, because a lot of the time, if it's not something which affects you, you're kind of going to be blind to it in the first place, because you may not even consider that it's an issue at all. It might not be something that would occur to you. So first of all, the question is who's writing the algorithms, and also who's looking at the results and who's asking the questions. And we know that computer science in general and data science especially are still not nearly as diverse as the general population. So I think we should be concerned about that and be working to fix it. Now, in terms of the actual statistical patterns, um, well, I think you have to ask what the system you're making is supposed to do in the first place. So let's say the obvious case would be something like making an algorithm that is deciding which candidates for a job application to accept or to take on to the next stage. Okay, that's pretty obvious because you could tell that if it's always only accepting people from some demographic group, it's probably biased. But when you start thinking about how to correct it, things start getting complicated. So obviously, if I was using some kind of word embeddings or something, I wouldn't want the inherent bias in them to trickle down into the decision. But once you start asking, okay, but what should be considered fair? There are a few different definitions of that, and they all contradict each other. So, and this kind of gets into some social questions in general where people talk about fairness. So one definition would be saying that every group basically should be equally represented in the results, which would mean like every demographic group should get an equal number of job offers. So that some people would consider that the most fair option. But on the other hand, it is possible that on average, there are more qualified applicants from one group than another. So that would mean that some groups would wind up having more qualified people being rejected than others. So again, whether you consider that fair or not is kind of subjective. But that's actually, yeah, that's what we would call demographic parity. So that's one type of fairness. On the other hand, another type of fairness would be saying if someone's qualified, then there shouldn't be any relationship between what group they're in and if they get the job. That's like conditional probability. So then I would say if someone's qualified for the job, it shouldn't, the probability they get offered the job should be equal, whether say they're male or female. Okay, that's what's called equalized odds. And so actually, except for the most trivial cases, those two different definitions are never equal to each other. There are other definitions of fairness as well, which are also not equivalent. So yeah, I would say that's a really difficult question.
Right. Now, what I think is interesting from the programming point of view is that you cannot succeed usually, if I understand, you know, what's happening out in industry. You usually cannot succeed, and this is definitely true with, like, say, medical records, just by erasing one slice of data. Like, say you did not want to discriminate against Black patients, and you just took that data off. Like, you know, it's somewhere in the metadata on a file and you just erase that data. So now it's like, it doesn't matter, but actually it doesn't work that way because of machine learning, right? Because like neighborhoods and income and health concerns all would cluster towards different demographic groups anyways, right? Like you don't see too many men with ovarian cancer.
Exactly. So yeah, machine learning algorithms are kind of good at inferring these things. So you can make the algorithm unaware of some feature like race or sex, meaning just not enter it as input, but they tend to be good at being able to infer things that are very correlated with it from other features. So usually that's not good enough.
Yeah. So how would you say, like, if you were trying to write an algorithm that was going to decide something about who would get, I don't know, transplants, and you wanted to make it gender neutral, how would you think about stripping out the information on sex? Is it even possible?
Well, I think that a logical thing to do would be to basically constrain the results. So again, it depends how you define fairness. But let's say I define it in terms of equalized odds to say that if someone is equally in need of a transplant, the odd that they receive it should be independent of, say, their gender. So then I could introduce that as a constraint, and that would affect how the model learns. So that's possible, yeah. But you have to decide if you consider that to be fair or not.
So generally speaking, I guess it probably is a good idea before you even write the algorithm to have these thoughts, processes in your head about what you've decided is the fair allotment for anything.
Right. Another example would be, this kind of went viral, but facial recognition algorithms. So they have a tendency where if you don't train them on a diverse set of faces, they may wind up not recognizing, say, certain races. So there were cases of facial recognition algorithms that were bad at recognizing Black faces because they weren't properly trained on them. So then it's possible that if you look at the percentage of times it recognizes a face correct in the population, it's high, but it might be that all the cases where it's failing are very concentrated among some demographic group. So again, I would say that to me that doesn't seem fair, but I would have to define what I consider to be fair. So
yeah, it's interesting practically because, you know, neither one of us works in the US, and a lot of these products go to the US or these other large markets where you have a really diverse population, but they may come from they may be essentially made in a very different population where people don't even realize what the meaning of these different demographic groups is. I mean, I'm imagining in my mind, like, you know, a group making a machine learning product in Korea, right? And now they have to make it fair and equitable for, like, let's say African Americans, Latinos, and other various groups in the States. Like, how are they going to do this? Like, it's very weird, you know?
And that goes back to what I said, that I think a lot of it is affected by who's asking the questions. So, you know, if say you were a group of researchers in Korea, would there be someone to ask the question of, will this work on the faces of, say, Black people? Um, so I think we should all be asking the questions, but I also think it can be hard to consider these questions if it's not something that you're personally exposed to.
Okay. So what do you think will happen? Because there's a risk that people will just get so sick of all the biases and failure, they'll just kind of give up on this in medicine. Like, what do you think could happen to sort of, you know, do you see any big changes coming down the line in terms of these issues?
Yeah, well, I feel cautiously optimistic because I see that this has become a topic a lot of people care about and are discussing. Um, and there's been progress in the field. And the other thing is, I really don't think there's an alternative because machine learning allows us to do things on a scale that was completely impossible before. So I'm not going to say that a computer is necessarily less biased than a person, but it's certainly able to do a lot more work more quickly. And so a lot of the things that machine learning is doing it's not really replaceable. Yeah, so I mean, I don't really think there's any going back, so it's better for us to figure out how to improve it.
Well, we could always go back. I mean, we could go back to the Stone Ages, right? Like you and I will be out of a job, but
Live in a cave, yeah.